So, okay, I think probably then we can already get started with everything. Just maybe explain the format a bit. This is something kind of new we're trying. So this is basically a training that we're planning on maybe doing every couple of weeks or so, just to mainly introduce new users to the flight planning using UgCS, different features that we have, because we know there's a bit of a learning curve initially, and that's why basically we decided that this might be a good idea, or at least a good thing to try. So we're also looking to your feedback about this. So basically during the training today, feel free to ask questions at any point. There's a Q&A section in here where you can type them, so I'm monitoring that. I hope you can see the screen okay. I hope there's nothing on the screen as well, because I'm trying out a new video setup, so I hope this should be fine. And if you just want to write something to me, you can also write it in the chat, but yep, I ask you please put all the questions in the Q&A section. And the recording of this training afterwards, this will be available on our YouTube channel. So even if you miss out on some parts of it, you will be able to kind of come back and revisit certain parts of it. So okay, I guess then without further ado, let's get started. So here you can, of course, already see UgCS screen open for me. If you have any technical issues, maybe like the video isn't working properly, just tell me. Otherwise, I hope this should be fine. I hope the audio is okay as well. So basically, first steps are connecting your drone. So for drone connection, as I'm assuming many of you already might know, for those who don't, if you go to our site, so UgCS.com, so for the drones that we support, mainly DJI drones, you can, by the way, see the full list here under supported drones. If you want to use any of the DJI drones, you will need to have our Android app. So if you go here, UgCS for DJI, you can actually either download the app directly from here, or if you're using a tablet or a mobile phone, then you can get it also on Google Play Store. But the most popular drone that people are using with UgCS is the DJI M300 drone. And for that, you can just use the direct download option, download the APK file, then you connect the smart controller to the computer, put the APK file in there, and then just install the app. And then once you open it up, next important step is that the computer as well as the smart controller are on the same network. Once they're on the same network, then the drone will appear as soon as you turn it on, and while you have UgCS for DJI app running, of course. So let's maybe then jump into UgCS interface itself, and I'll just explain kind of the basics to you, as well as if we'll have time, we'll also dive into a bit more advanced features for flight planning. So regarding the interface itself here, now it's kind of completely empty in the sense that, of course, you can see there's no demo mission, nothing like that. So to get to the state, you need to go here and then press here on create new mission. So then this will basically allow you to get to where I'm currently, because this means that any drone that you have had here previously, this drone will now be taken away from here. So to start with, I'll go ahead and add my drone over here. So in this case, I'll be using the emulator, but I have just like renamed it to DJI M300. And it's also using the M300 profile. I just prefer to use this for any demos. So then next, once you have this drone, essentially the interface is divided into two parts. Everything that's here on the right side, this is concerning your drone control. So from here, you'll see multiple drones if you have multiple drones connected simultaneously. So for example, if you have two emulator drones, you are able to switch between them, and same goes for real DJI drones. Next below that, you have the telemetry window. So for whichever drone you have selected, this will display all the relevant telemetry information. For now, I'll just remove this other drone from here. So we only have the M300. And then below that, this is where you have all the commands that you can send to the drone. Also, when we'll have the route, you also have the upload command over here. So basically all the commands, they also go in there. So if this side is for drone control, then everything that's on the left side, so this will be concerning your route planning. So to add a new route, you can simply press here on this button, add new route, and then let's create something. So let's just start up very simple. Let's create a route from waypoints. Let's click here on next, and the screen, we just need to select what drone we are using, in this case, the M300. click next. And in this case, if you want, you can change some of these parameters. I'm just going to leave them to their default values. In some cases, you might want to change the action on loss of RC or the maximum altitude above ground. But in this case, I'll just leave these parameters as they are, click on OK. And so now you can see that on the left side of the screen, we're now presented with different tools that we can use for flight planning. Just don't get overwhelmed by them. In reality, it's quite simple, and you probably won't use most of them, but I think some of them will still be very useful for you. So the most basic one is the waypoint tool. So how this works is we can just zoom in anywhere here on the map. And then with the waypoint tool selected, we can hold down the shift button and then just click here on the map to place the waypoints like so. You can also select multiple waypoints, holding the control key like so. And so then you can, for example, change the altitude on the selected waypoints. And similarly, you can also move them around like so, or you can do Control A to select all of them, and then you can move around the whole route. Just a second, I'm going to try to answer some of the questions. If I see some that I can kind of answer now. Yeah, in case you're struggling with the error that says waypoint exceeding height limit, there's a few ways where you can check that. So number one is check our mobile app, because you can also set the maximum height in there. And the next, check the drone profile. But I think most likely if you're getting the DJI error, so this looks like it's from DJI SDK, not from UgCS, then most likely check the app and make sure that you have the maximum altitude set there as well. That's not set to, for example, 50 meters, but it's set higher instead. So then with the waypoints, let's then go further. So here, of course, you can see we have the parameters for latitude, longitude that are set automatically, as well as the altitude. If you want to change them also, you can do Control A, and then, for example, you can now set the altitude for all of these points together. So we can now set them back to 50 meters AGL. Next, you have the flight speed, and then below that, you have the turn type. For DJI drones, you're going to have two different turn types. You're going to have stop and turn, and you're going to have adaptive bank turn type. I prefer to use adaptive bank turn because it's just a lot more efficient when you're flying through the corners. Then below that, you have two checkboxes for avoiding obstacles and for avoiding terrain. For now, we're just going to leave them as they are to their default values. And then below that, you have the altitude mode. So again, by default, this is set to AGL. If you want to fly according to the above median sea level altitude, then you can change this to AMSL. And you can actually see that here also now the altitude has changed. And so now you can set it to AMSL. So this means that it won't really follow the terrain. It will just be simply set at a certain AMSL altitude. In this case, however, I'll set this back to AGL altitude. And then you can see that now the route is calculated. And so now if we go here into parameters and then show elevation, you can also see this is the elevation profile. So by default, in all cases, UgCS will follow the terrain that it has. So by default, we're using SRTM4 terrain elevation data, but you can use your own terrain elevation data as well. And I think we'll get to that in a moment. There's a question. So what does avoid terrain mean? So essentially, this means that if you have, for example, a waypoint that, let's maybe move them a bit higher, just so you can see it a bit better. This means that in certain cases, when, for example, two waypoints are, let's maybe do it like so. Let's select these two guys. So kind of like this, right? And so now you can see if we have, I'll see if it calculates, yeah. So if we have this avoid terrain checkbox here selected, you can see that now UgCS is basically adding these additional waypoints to make the drone, in this case, will fly kind of above the mountain. And if you don't have that, then I think in this case, let's see how it calculates. In this case, we also not really, let's just check like this. So let's move it. I think once you move it now, we should get, yeah, so in this case also it does, I know there's some rare cases when you don't have the avoid terrain option, then you might get an error in those cases. But I think in most cases, you know, it will still try to calculate the route around any obstacles or any terrain that it has. Let's see, like so. Yeah, same thing. Well, in this case, you can see it depends on how, what's the exact elevation at that point. So I hope it's more or less understandable. But yeah, so this is basically how you can construct a very simple mission. And I think now one thing I also wanted to show to you guys is, so how can you add different actions to basically make the drone behave in a different way in, let's say, a simple route like this, and then we'll get to planning a bit more advanced flights. So for example, now you can see that for each of these waypoints, we have certain actions underneath here that we can add. For example, we can add a wait action to the waypoint. We can also, by the way, have multiple of them selected, and then we can add these actions to multiple waypoints simultaneously. So we can add a wait action. We can add a point of interest, meaning that the drone will look towards a certain point as it will be flying through the segment. We can do change yaw, meaning that the drone will keep either constant heading towards north, or maybe just click here so you can see. So it can keep either constant heading with respect to next waypoint or constant heading with respect to north. Next, we have the ability to also set the camera attitude. In most cases, this is used to set the camera tilt to a certain angle. So, the camera is, for example, facing exactly 90 degrees downwards. And then similarly, also, you can adjust these other values as well if you need to. Next, we have the set camera mode. So for this, you can make the camera do a shot, or you can make it start or stop the recording. After that, we have these two actions that aren't normally used in the photogrammetry mission. So we have set camera by time, and we have set camera by distance. These I'll get to in a moment once we get to the photogrammetry, flight planning. And then after that, you have the panorama, which you can use to basically make the drone either do a 360 video or do a 360 photo at that location, where you can adjust things such as angular step, velocity, weighting per each sector, and so on. And then if you're using the LiDAR sensor, then even though for all the LiDAR specific tools like LiDAR area and LiDAR corridor, we have the LiDAR sensor automatically start the data recording. In this case, if you just want to plan a route with waypoints, if you have UgCS expert or enterprise license, then you can also do the set LiDAR recording on or off. So you can add this action to also control the LiDAR sensor. And so I think now, let me just maybe remove these actions real quick. I think I'll just quickly explain how do you launch drone on the mission, and then we can go to planning the photogrammetry flight. So, well, also actually, for example, I think I'll maybe do set yaw, for example, 90, just so you can see this as well at the same time. So now we have the emulator drone, and then to launch it, you need to do upload. But with the emulator, the trick is you need to do the upload 2 times, so it also adjusts the altitude to where it's supposed to be. With a real drone, you just do the upload once, and then that's it. So now after this, you do arm on the drone. And so now once the drone is armed, you can press on auto mode to launch the drone on the mission. Again, just keep in mind that with DJI drones, there is not going to be any need to press on arm. So DJI drones, you simply press on upload, and then after that, you press on auto mode. So now you can see actually the drone is gaining altitude. And so once it will reach the altitude of 50 meters, it will proceed on the planned route. I'll see if there's any other questions. I think I'll cover the questions once we get to them, but I think some of them I might actually try to answer now. So first, let's maybe go into the photogrammetry flight planning. This will be our next logical step here. So let's again go here to add new route, and then let's create the photogrammetry flight. So now let's go next. Let's select the drone that we want to use. In this case, again, I'll just use the M300. And so now we can go here a bit further. And for example, here we can try to do a photogrammetry mission. So for that, let's select here the photogrammetry tool. And so then with this tool selected, first, I'll just mark out the area, and then I'll tell you about what things are important when you're planning a photogrammetry flight. So now with this tool selected here, I can just again hold down on the shift button and then just basically mark out the area that I would like the drone to scan. So maybe something like that. Press enter, and so now you might have to adjust the direction angle a bit, so it's exactly parallel to these boundary lines. And so now I think I'll just do some more adjustment here, and then that should be okay. All right, perfect. So now once we have this photogrammetry flight calculated, let's review some of the parameters, because by default, the first time when you'll create this, some of the fields here will be blank. So I think it makes sense to maybe go through that. So let's go through here. So first thing is the camera. So based on the camera that you're using, the photogrammetry will be calculated in a different way. So it also always takes into account the specific camera sensor that you are using. In this case, you can see we're using the DJI Zenmuse H20 wide camera. So if you're using any other camera, in this case for the M300, we have the H20, we have the P1, and we have the L1 camera. But if you have some custom camera that you want to use, you can actually add that by going here to the main menu, then going into where you have profiles. Then just find the profile of your drone. In this case, this would be the DJI M300, and then click here on Edit. So then here under Payloads, you can click here on Add, and then add any camera from the list that you are using. In case that your camera is not on the list, I saw there was a question also about the FLIR camera. So if the camera that you want to use is not here on this list, what should you do? In that case, you can actually add the camera to UgCS. So to do this, you can go here into Payloads. And so then you can click here on Create New. So you can add any camera avatar that you want to use. Although in this case, you can see, for example, we have the FLIR cameras as well. So maybe let's select this one. And you can, for example, add some name to it and then add these parameters. So the most important ones would be what is the weight of the camera. I'm sorry, it's in kilograms, so it should be 0.1. What's the true focal length? What's the sensor width, height, horizontal and vertical resolution, as well as, if you know, then the minimum triggering interval. So once you fill all of this out, then let's actually just fill this out real quick. So let's do something like 9 millimeters, and for the sensor, let's do something like I'm sorry, it's the resolution. I'm really not sure how many millimeters this is. I'm just going to write some random values in here. Okay, so now once you have this camera, then you can go here into profiles for the M300, for example. Then you can go here into Edit, and then you can add your own custom camera. So you can press here on Add. And so now I think, was this the one? No, this was a different one that I created. Let's maybe scroll down a bit. Let's try to find it. I think it's alphabetical the way it sorts this. So yeah, but basically then you go here and then from the list, yeah, here it is actually. So then you just add the camera that you have created. And so then this means that all the flights, including the photogrammetry as well as the corridor scan, they will then be calculated using the parameters of your own custom camera. Yep. And so I think while we are actually here in the screen, a couple of other things I wanted to show you that might be useful. First one is the fence radius. So in case you want the drone to fly further than 500 meters in a single route, in that case, I recommend that you change this fence radius value. Instead of using the 500 one, which is here by default, you can use whichever value you want in your specific case. For the demo drone, I'll just add a couple of zeros here, but ideally you should set it to the fence radius that you're comfortable with and the fence radius where you are normally flying your drone. And same actually goes for the fence altitude as well. So with that all done, let's click here on Save, and then we can go back to our flight planning. So now let's again go here to the photogrammetry mission. I'll just see what other questions do you have. Yeah, the question about the dual gimbal use. You can't really specify two cameras simultaneously. Sorry. So this means that whichever camera you have selected here, this is the camera that at least the flight will be calculated with. With some custom drones, of course, it's possible to make it so that both cameras will trigger simultaneously, but still the flight will only be calculated using one of the cameras that you choose. So I think now let's maybe go then a bit further through here. So for the photogrammetry flight, let's then kind of review what parameters we have here. So first one was the camera. And then if we go here to show elevation, so here you can actually see the elevation profile over which we'll now be flying with the photogrammetry mission. You can see that the estimated duration here is approximately 13 minutes, as well as what's the minimum and what's the maximum altitude. So for the minimum and maximum altitude, one parameter that's quite useful is this AGL tolerance parameter. So basically, by default, it's going to be 3 meters. And this means that if the terrain changes by more than 3 meters, then UgCS will place an additional waypoint in here. This basically means that also that the lower you set this value, the more waypoints will be added and the more closely the drone will follow the terrain. In this case, if I then change this to, for example, 1 meter, then you should now see that the elevation profile will be more exact. So actually you can now see that here the maximum altitude AGL is 97 meters, and then the minimum is 97 and the maximum is 98 meters. So, and then next you have the forward and the side overlap values. So these are in percentage. I think by default, the default values, if I'm not mistaken, these are 60 and 30%. In this case, you can see that I have both of them set to 80. I just kind of prefer it that way because I think, you know, the more overlap you get, then the easier it's going to be on the stitching software once you get to that. With other things, yeah, so here you have the direction angle. This is the angle that you have set in here. Also, if that's necessary, if you want to cover this area with a double grid, you can, because then we have also this checkbox for that. So if you check the double grid option, then you'll now see how the whole area can be covered with a double grid if you want to cover it from 2 different directions. So in this case, for now, I'll just uncheck that. And so you can see that by default for the photogrammetry mission, we have the set camera by distance action that was added here. So this means that the camera will automatically be triggered every certain number of meters. Personally, I prefer to use set camera by time. So in my case, what I'll do, I'll just click here on remove, and then we can go here to set camera by time. And let's now add this action. Then next, if you also want the camera to automatically point 90 degrees downwards, for example, you can go here to set camera attitude, and then here under tilt, you can enter the value of 90 degrees. And using these arrows, you can press here to move the action as the first one. And so then after that, this will be followed by the set camera by time action. One question I get from time to time is, so is it necessary or is it mandatory to add one waypoint? Like, do you need to add a takeoff point and the landing point before and after the mission? The answer is no, it's not really necessary. There are some rare drones where you would need to have a takeoff action, specifically VTOL drones. But I think most modern drones should be okay with just having waypoints in there. And that's why for DJI drones, even though you can see here, we have the takeoff and the landing actions, I'm not really using them. And also, I do prefer to have a waypoint before the photogrammetry flight, but again, it's not mandatory to have. You can simply have a photogrammetry flight like this and then fly it. But in this case, you know, let's say you have constructed that flight and you are, for example, located somewhere in here. So this means that then once you send the drone on the mission, first it will fly to the furthest corner and then it will kind of start the flight from here. And in this case, also you can see it will end the flight in one of the furthest corners. What I prefer to do in this case is I like to add one waypoint before the photogrammetry flight and one waypoint after it. So to do that, you can go here to add first waypoint, select it, and then using shift click, you can simply place it before the photogrammetry flight. And then you can see that actually now the flight is starting on the same side where we are located, and it's also ending on the same side. And actually, if we now take this point and we drag it around, you can see how it snaps to the closest corner of the photogrammetry area. So I'll now add one waypoint to where we'll have the takeoff location of the drone. Then using these arrows that are here, or using the bracket buttons on your keyboard, you can move around through these segments. So whichever segment you have selected, once you add a new one, this will be added after it, except if you do the add first waypoint, which will add it at the very beginning. So now after the photogrammetry tool, I'll then again select here the waypoint tool and then again shift click on the map to place it, and I'll just drag it in the same exact spot, more or less. And now you can see that once the route is being calculated, then the drone will take off here, go and fly the whole photogrammetry route, and then come back to the same exact location. Again, just to reiterate, it's not mandatory to have these points before and after. You can simply have your photogrammetry or some other area scan flight. I just prefer to do it this way. I think it's a bit better, and it just gives me this peace of mind. I know that the drone will start the flight as close as it can to where I am located currently. So in essence, yeah, this just basically gives you a bit more of control. So then we can go here. We'll see if there's any other parameters. Oh, I remember today, this is already the second training that I'm doing. And in the previous one question we had is, so is the drone doing the pictures all through the flight, or is it doing them only on these like longer passes? And so this is controlled by this parameter here under action execution. So currently it's set to forward passes, meaning that the drone will only take the pictures on these like longer forward passes instead of, where it's turning around. If you wanted to take the pictures all through the route, what you can do is you can simply select here every point, and then this means that the drone will basically trigger the camera at every point, including these small side passes. So yeah, that's the main thing as far as planning photogrammetry missions goes. And keep in mind, all of them are planned using the ground resolution parameter. So this basically controls how high will the drone be at each point. And this also, of course, and most importantly, controls what will be the resolution of the result. So this means in this case, if we have it set to 3.5 centimeters, this means that 1 pixel in the image will correspond to 3.5 centimeters on the ground. So the height will depend on two things. First, on what camera is used and the camera parameters, and second is on the ground resolution parameter. So if we go here, we can, for example, see that currently the AGL altitude that's calculated is 97 meters. And for example, if we wanted to bring this down a bit, if we set this to, for example, 3 meters instead, so now you should see that the altitude is now lower. So now the altitude is at 83 meters. So we can go here again, and then we can click on show elevation to review the elevation profile again. And yeah, so this is where you can see again, minimum altitude. This is because of the waypoints that we have, as well as the maximum altitude and total estimated duration. I think also then maybe we can launch the drone on this mission. So to do this for the emulator drone, I'll just disarm it first. And now I can do upload. Again, for the emulator, you need to do this 2 times. And then I can do ARM and I can do auto mode on the drone. Another thing or a question that many people who are new to UgCS have is, so how can you fly a mission with changing the battery? What does that look like? What do you need to do exactly? Answer is very simple. So once you have flown a certain part of the route, and then you need to basically restart it after have changed the battery on the drone, there's 2 options what you can do. So then here, once you press on upload, you can see you have 2 options. You have either start route from the beginning, or you have the option to start a route from a certain waypoint. And so then when you mouse over any waypoint in UgCS Map, then you'll see what waypoint number this is. And then, for example, you can input this exact waypoint number in here. And so then, for example, you can now see the drones already moving towards this point. For DJI drones, there is a 3rd option there. So DJI drones actually will remember the last point at which they stopped the mission, or kind of how far have they flown in it. So then there'll be like a 3rd option that says continue route. So this will basically mean that the drone will be able to automatically continue the route from the last point where it left off without you having to input the waypoint number there explicitly. So I hope this also kind of covers that. So I think then from the photogrammetry, let's move then a bit further. And what I also want to show you is I want to show you the corridor scan function that we have. So for that, let's go here on add new route, and then let's create corridor scan. By the way, if in case you didn't know, it's also possible to create routes in UgCS by importing KML or CSV files. Similarly, if you export the route, it will be exported to a JSON file, and then you can also import this JSON file. So basically, if you select this import from file, then this means you are able to use KML, CSV, and UgCS JSON files to create the routes from them. For example, if you have some area selected as a KML file, then you can import this, and UgCS will automatically build either an area scan or photogrammetry. It's whichever you choose during the import. And similarly, if you also have a line in a KML file, then this line can be imported, for example, either as waypoints or as a corridor scan. So, but now let's create this from scratch. Let's click on next, and then again, let's just select our drone and then click next and okay. I see the question about the coordinate system. So basically, we're only using UgCS 84 coordinate system. You can define the coordinates either. Let's maybe go here. You can either have them in the decimal format, or you can have them as degrees, hours, minutes, and seconds. It's also possible, but yeah, by default I'm using this one. But yeah, as far as the coordinate system goes, it's only the UgCS 84, so you can't really use other systems. If you have a way how you can, if you have some KML file that you can transfer to this coordinate system, then UgCS can accept it. So just mark this as answered. I'm not sure what's the question about return to home definition. What do you specifically mean by that? With the return home, I'll just maybe quickly explain here. So if you go here to parameters, you'll see that we have the return home altitude, which is specified above the takeoff point. So from wherever the drone takes off, keep in mind that 50 meters, this will be where the drone will return back home. Normally, it also works in the following way, that if the drone is higher than the return home altitude, then it will come back home at whichever altitude it is, and then it will start to land. In the case that the drone is lower than the return home altitude, then it will climb up to the return home altitude before it will be starting to come back. But keep in mind, always you need to keep in mind what's the terrain like, because in some cases, if you have the return home altitude, for example, set at 50 meters above takeoff point, and then the drone is somewhere else where there's an obstacle, then, well, just keep in mind whether the drone has the obstacle detection system or not. So you always have to be very careful about that. Okay, so now we have this corridor mission that we can plan. So let's maybe then proceed with this. So then let's go here to the corridor mapping. We have two different tools that we can use for the corridor. We can either use the normal corridor mapping tool, or we can use the LiDAR corridor. Sorry. In this case, I'll just use the normal one. And it's quite similar in the sense to the photogrammetry one. So you can define a certain ground resolution. In this case, I think I'll just use ground resolution of 3, and I'll use the same camera as before. So I'll just use the wide H20 camera. So then in here, to plan the corridor scan, simply you can hold down the shift button, and then you can place these points along any line that you want to, and like so. Then you can press on Enter key to complete the figure. And then if you want to make some fine-tune adjustments, you can actually do that. So for example, here you can see it's not following our imaginary path quite closely. So you can actually grab these middle points at any location, that you can basically just drag them out so that they match up a bit closer to how the corridor is actually moving throughout the area. And you can basically add as many points as you need, and you can make as many adjustments to basically make it as accurate as it's necessary for you. And so now once you have planned the corridor flight, then the next thing is that you can actually adjust what should be the width of the corridor. In this case, you can see it's set to 30 meters, which means that this corridor is only going one way. And then basically, the wider you make it, then UgCS will eventually add an additional line for the drone to come back. And then if you make it even wider, then you'll have another line that will make the drone fly to the further end of the corridor again. So in that case, we can then play around with this width parameter. So for example, we can set this to something like 70 meters. I think we might need to do just a bit more. Let's maybe do something like 100. And might need to do a bit more. Just a second. Yeah, so in this case, now you can see that now the drone's flying, there and back again. And I think also now you can see we have the forward and the side overlap. It's currently set to 30% and 60% and 30%. If we also go ahead and change these values, then I think you should also see that now the corridor will also be, I think there should now be a few lines going there and back on the corridor. Yeah, so now we have 2, and I think if we then go ahead and increase the width even more, then we should have even more lines there. But in most cases, I suppose what you'd want the drone to fly there and back again on the corridor scan, which is exactly what's happening in this case. Yeah, I'm just reading the question that's there. So can you transfer the JSON file to the pilot, and will they have all the necessary information? Yeah, so basically what you would do in that case, so for each license of UgCS, you actually have 2 activations. So it's intended, let's say if you purchase, for example, UgCS Pro perpetual license, this means you can activate it in the office computer and on the pilot's computer. So in that case, what you would do is with any route that you have planned in here, you would go here to parameters, and then you would go to export route. So then the route will be exported into JSON format, and then the JSON route you can simply send to the drone pilot in the field over email, or whichever method you use for file sharing, maybe some shared cloud folder. Then they can get the route and they can upload it to their drone and fly. Similarly, actually, you can export not only routes, you can export whole missions. So for example, if you have a few flights that have to be done in a certain area, then what you can do is you can go here to menu, and then you can do export mission. So then the whole mission will actually be exported into JSON files. So this means that all of the contents of the mission, including any custom drone profiles, including all of the routes within the mission, these will be exported, and then the pilot in the field can, take the whole mission and then can kind of go route by route as they fly them. Alternatively, it's also actually possible to export any route from UgCS into KML format that can be accepted by DJI Pilot. So for example, if you want to fly with DJI Pilot, also you can go here into export to KML, and then you can select the format as place marks, and then the altitude you can select a relative to ground under first waypoint. And then once you export this to KML, then you are able to open this up either in DJI Pilot or DJI Pilot 2 app, and then fly the same route. One thing to note is though that the actions are not exported, so these you might need to add additionally in DJI Pilot app. But if you want to use UgCS for DJI app, which is the recommended way, then while you are in the office, it's also possible to synchronize the routes from UgCS desktop to the mobile device. So you can simply load all the routes for offline use, and then later on you will be able to select them and fly them. However, keep in mind that making any changes to the route, this is available only in the desktop version that's here. So I hope I answered that question that you had. Oh, so a question. So what's the difference between corridor points and waypoints in a photogrammetry plan? So main difference here is that with the corridor, the drone is flying essentially in this complex trajectory, right? So keep in mind that with the corridor, you can basically make it fly as far as you need to. Whereas with the photogrammetry, it basically takes a certain polygon, right? So the main difference between these is that the photogrammetry mission, it's constructed on a polygon basis. So let me just unlock the route. So yeah, just select some polygon on the map, and then based on this polygon values, the route is being calculated. With the corridor, what's different is that the corridor is basically constructed based on like a line of points instead of a polygon. So that's the primary difference. And especially if you want to maybe fly some really long lines, let's say we have some people who are using this for mapping areas where fiber optics cables will be installed, for mapping power lines, then the corridor scan is the one that you would want to use in those cases. Another thing I can maybe just quickly show you while we have some time is that any route in UgCS, if you need to make some customizations to it, you can actually export it. Well, not export it, but you can change it to waypoints. What I mean by that is that here, for example, you can see we have this corridor route. And then if we go here into parameters, you have the option route to waypoints. So now if we press on this, so now we can go back here, and using this, you can hide the original route. And so now you can see we have the same route, but it's only constructed of waypoints. So then we can, for example, select all of them. You can move it around, or you can select any individual points and you can make some adjustments. Why would you want to do that? Let's say maybe you have some case where, for example, in the corridor scan, you want to kind of include another smaller corridor. So then you can add, then you can select this point, and then with this point selected, you can, for example, go here again to corridor mapping, and then you can map out a few more points where you want the drone to fly. And then after this, the drone will fly there, then it will fly back again, do the small corridor inside of that one. And so then it will continue here. And then similarly, if you want the drone to maybe do the same thing here, again, you can just select this point and then again, go to corridor mapping. And yeah, just like map out certain parts of the map. And then kind of continue on the way back. Of course, this is on quite a small area, relatively speaking, but on larger areas, you know, I suppose you can imagine how useful would this feature be. Oh, so I see a question from Christopher. So about using your own TIFF file for the elevation. Let's then go here. So I suppose the problem you're saying is that it's below, right? So you're saying that it seems to be below the map on the screen. I'm assuming you mean elevation and not the map, because there's two different things. So I'll just quickly maybe explain this. Here in UgCS, you can customize the map and you can customize the elevation source. So maybe let's start off. The simplest one will probably be the map. So I'll just explain this and then we can get into the elevation. So by default, we are using Google Satellite base map. Sorry, we're using Google Hybrid, but you know it's close enough. And so then, if you want, for example, change what base map you're using, you can select any of the other ones that are here, and then you can do set base map. And so then now you can see that the base map has actually now been changed. If you want, you can actually import the map from some other sources. So instead of using GeoServer, you can also use some external VMS source. And yeah, you can just kind of paste the link here and then add the name for it, and then you can add it. So you're not only limited to Google and Bing, for example, you can also use any other map source that you want, as long as it has this valid link. And then additionally, you can also use your own map overlays. So in this case, I have already one overlay imported. Just maybe demonstrate how can you import them. So let's add some other map overlay. You can see I already have a few empty ones here. So with this one selected, you can go here into upload, and then you need to select the TIFF file of the map overlay that you want to use. In this case, this would be the orthophoto.tiff, and then you would go to select, and then it will be uploaded. In this case, I already have it loaded. So this is this one. And so then once you have it, you can just use these arrows to basically move it into the overlay. So now let's go and take a look at it. Let's click here on focus. And so now we're taken to the place on the map where we have this overlay. This is actually the location of our office, but just to demonstrate maybe the difference in the accuracy of maps. So for example, if you zoom in here, so you can see what's the resolution of the default Google map, and then what's the resolution of the map that was done by our drone. Even though this was just like one quick flight that we did over the office, you can see basically the difference in the level of detail. It's also very useful for flight planning. One good example would be that in 2019, we were on an expedition in Greenland, where we also had to fly and cover a certain area with ground penetrating radar with the drone. And then also we didn't, even though we had the elevation of the area, we didn't really have any map, which made flight planning quite difficult because we didn't have any visual understanding of, how far we'd be sending drone. I mean, sure, we can measure it. There's also measurement tools here, but it was a bit difficult since we needed to have some orienteers, at least, where's the mountain, where's the camp, things like that. Because otherwise on the map, well, I'll just demonstrate here, but it just looked, well, basically everything just looked white in same way how here just everything looks green, And so then having our own map was really, really useful. We did use, in that case, UgCS Mapper, if you're not familiar with that. So we actually have it here on, let's maybe go to, so mapper.ugcs.com. So this is where you can read a bit about it if you're interested. It's just a quick processing solution. You can also, by the way, use it for multispectral. And I think I have some example of it. This is the one that also I have actually this file imported from. Let me just maybe quickly open this up. So here you can see the result. So this is the map that was processed. And then as we scroll down, you can see it also attempts to create the elevation profile, even though in this case, since the camera was facing exactly 90 degrees downwards, then, it was a bit problematic with this. But the cool thing about Mapper is you can actually use it offline. So there's no need to have any internet connection, same as for UgCS. You can use this in the middle of nowhere, and it actually stitches the map relatively quickly, and you can then use it for further flight planning. So going back to where we were. Yeah, so here you can see we have the map imported. And then similarly, if we go here to map layers and then elevation, you can see we have by default, we're using SRTM4, turn elevation data, and then north of 60-degree latitude, we have a different elevation data over there. But if you're using your own elevation data, like I'm doing here in the specific location, you can see you can actually also change the priority of this layer. So maybe that's what was the thing why this wasn't really prioritized. So make sure that you have set this as the top priority layer in this case, although I think this should be set like that by default. I'm just reading a question here. So just a second. Is there a way to upload a modified route using only my phone and laptop? Yeah, I'll maybe then just quickly explain how would you normally use UgCS in a location when there's no internet. So for that, the most critical thing is that you have the map cached for offline use. Also, one thing is if you need to move to where you have the drone or to where you have the route, I think a lot of people don't really know this. At least I have a feeling like that, but you can basically double click on the name of the drone. You'll be taken to exactly where the drone is. And similarly, you can also double click on any flight plan, and then also you'll be taken to where exactly you have this flight plan. But for offline map functionality, we have it here in map options, map layers, and offline maps. This is experimental currently because previously you could only catch smaller areas, and now you can catch quite large areas in UgCS. If you want to use this feature for offline maps, what you need to do is you need to go here into menu and then main menu, then go into configuration and experimental features, and then make sure that this is checked. So this enable experimental features. Once this is checked, you can go back here. So I'll just close the window blinds. Otherwise, it's already close to sunset here in Riga. Well, not close, but it's evening, so the sun's just coming in. So yeah, once you have this enabled, you can go here into map options, map layers, and then here into offline maps. And so then if you want to catch a certain map region, what you need to do is you need to press here on add, or alternatively, I'll show you a bit of a quicker way, even without going, in there, once you have this experimental feature enabled, you can basically right click anywhere on the map in the UgCS, and then you can simply select offline map. And with the selected, you can then already start basically placing the points in here. So we can do something like so. Oh, actually, I might need to slightly adjust this. So, you can still make a lot of adjustments here if you need to. The maximum size of a single area that you can catch for offline use is 100 square kilometers. You can catch multiple areas like that, but that's currently the maximum. So now this region is selected. What was the total area of this? I think it should be shown somewhere. We might need to enter then let's also then select Google Satellite, and then let's enter some name for it. And so then we can press here on create. Oh, so actually here, sorry, I didn't just notice. So here in the middle, we have the total area. In this case, it's 2.5 square kilometers. But so like I said, you can catch area in a size of up to 100 square kilometers per single area. So this means you can basically catch an area that's 50 times as large as this one. Keep in mind that especially for large areas, it might take some time to catch them. So let's say for 100 square kilometers, it might take an hour or two to catch the map because it's still quite a large map, but plus there's like many different layers depending on the zoom level that you'll use. But yeah, this feature is here and it works. And so then with this selected, we can press here on create. And so now you can see that this map is being now cached to the local geographic server. So it's a server that's running here locally on your computer. So if you go here to UgCS Service Manager, you'll see what services we have running. So this is the geo server that's storing all the maps. Okay, I'll just now see what other, I hope I answered the question, but using UgCS offline. So then the main thing is make sure you have the map loaded there for offline use in places where the internet connectivity is quite limited. And yeah, so then basically you can use this function to select certain regions and then load them for offline use. So I just need to get, yeah, there's my mouse cursor. And I'll just maybe quickly go here to where I have already a couple of regions, just so you can see kind of how it looks like. And so you can see that then I can basically, it also highlights when I select a certain region, you can use the focus button to focus in on them. And if you no longer need the map from a certain region, you can just press here on remove, and then this region will be removed from the cache. So now let's go here. You can see this is still being cached, but that's fine. We can just like leave it as a background process basically. And then once it's done, it will be shown over there. I'll see if there are any other questions here. There seem to be some. Oh yeah, if you have some issues with the TIFF file, we might need to review the specific file and what's the problem with that. In that case, Christopher, I do recommend maybe you send us an email at support@ugcs.com. We can take a look at your specific file and yeah, maybe give you some recommendations on any adjustments you could make to that. So I'll just put here in the chat. So the email is support@ugcs.com. Plus, we also have a group on Facebook. So if you actually go here, I think it also should be on our main site. So let me just quickly try to find it. So if you go to UgCS.com and then support, then I think I wanted to make it a lot more visible. Yeah, so over here you can see we have our UgCS user group on Facebook. So I'm assuming some of you already might be there, but for those of you who are not yet there, I think it's also quite a good resource where you can ask for help from other drone pilots who are using UgCS, and also we are there as well. So if there's anything that comes up, maybe any technical problem, something like that, we also try to solve them there. If it's something a bit more complicated, then we ask you normally to also send the email to our support team. But if it's something like quite simple, then also like even on the weekends, sometimes we're just like answering the questions there. So it's a really good resource, I think, for you to also exploit, if I can say it like that. Okay, so let's see if there are any other questions. Seems that there are a few indeed. Normally there's some colleagues who are assisting with answering the questions, but now it's only me. So sorry if I don't get to your question. I'll try to answer as many of them as I can. Oh yeah, so one question is in the flight, how can you keep direction of the camera in the same angle as in when the drone turns, camera will also change. In case you wanted the camera to, for example, be at some constant angle, then one recommendation I can give is you can try to use the change yaw action in that case. So for example, for the photogrammetry flight, let's maybe go here. So if you want to change the yaw of the drone, so then what you can actually do is you can go here to change yaw, and then you can set the yaw with respect to north. If you want the yaw to be the same as the direction angle, then for example, you can take the same value from the direction angle, input this here. And so then this means that the drone all through the flight will be looking towards the same direction as this direction arrow. And sorry, for some reason, this doesn't like this value. Hopefully now it should be okay. Yep. And so then this means even if you have the double grid, then the drone will still maintain a constant camera facing towards this this direction. So I hope that helps. If you want to construct two separate area scans with, well, basically camera facing a different direction each time, I would do that in the following way. So instead of using double grid or like two photogrammetry flights, what we can then do, I'll just maybe delete these initial waypoints because they are in our way a bit. And so now once we have only this photogrammetry tool, right? So then what we can do is we can go here into parameters, and then we can go to duplicate route. So you can basically copy routes quite easily like that. So now I can actually rename this. So let's do, yeah, like photogrammetry 90. And so then on this next one, we can simply increase this direction angle by 90 degrees. So this should make it 107 degrees. So this is, again, basically the same double grid. And if you want, you can actually combine both of them. So you can take the first one, and then you can go into, let's see what it was, merge route. So then click on merge routes, and then you can select the route with which you want to basically combine this. You also have the option to either add it at the end or at the beginning, and then you can click here on merge. And so then we'll basically, both of them will be put together in one single large photogrammetry route. And yeah, then hopefully, yeah, it says photogrammetry united. So hopefully then this would help. Yep, let me see any other questions that you guys might have. Yeah, so do you need Wi-Fi to upload the flight from the computer to the drone once you are in the field? Also, a very, very good question. You don't need the internet to upload the route from the computer to the drone. Just want to make that clear. There's no internet needed. However, it's good to have some local network if you can't have internet as well. How we're normally solving this in the field when we're going there, there's basically two main solutions. One is that you can simply just take, you always have your mobile phone with you. Connect both of them. If that's not possible, I know we have some customers who, for example, they're using their computer's Wi-Fi adapter to basically make a hotspot and then just like connect the Android device to the computer's hotspot there in the field. Another option is if you maybe don't want to use the laptop in the field at all, then like I said, you can just catch the routes for offline use of the mobile device so that you can just go click open route on the route that you want to open up, and then you can do so on a few routes that you know you will want to fly. And yeah, then also there's no need to like open the laptop, you know, then try to make sure it connects and so on. So yeah, but when I go to the field personally, I still like to have the laptop with me just in case I need to do some changes to the route, or also actually for monitoring how the drone is flying, because here, you know, you can see quite detailed telemetry. So normally, you know, you just have, let's say if you have some car with you, just like keep the laptop in the car, you know, hold the remote controller in your hands, then make sure everything's okay with the route, upload it, and then just send the drone on the mission. So let's go here. Oh yeah, actually very good. Thank you, Evandro. Hope I pronounced your name correctly for reminding me of this. So yeah, you have a question about doing a vertical flight plan. So I actually wanted to show this to you in this training. So very good that you reminded me of this. So let's do the vertical plan, flight plan real quick. So let's just again select the DJI M300. You can actually import 3D buildings in UgCS, but it's not mandatory for doing vertical flight planning. So in this case, I'll just maybe demonstrate this without that. So here we have some building, but let's imagine this small farmhouses, some taller building, some skyscraper, something like that. So in UgCS here, we have also the vertical scan tool. So let's then select this. And then basically this allows us to scan vertical objects. This is based on what camera you're using. So in this case, also we'll need to select this. I think I'll select the wide camera. So then let's maybe just proceed with planning the flight around it. I'll just double check. I might have some 3D building, but no, I think I don't. At least not in here. It'll just take a bit too long to import it. So let's do it without any 3D buildings. So now again, I'll just hold down the shift button, and then like so, you can put these points here on the map. I'm just going to place them kind of out like this initially, and then I can just make some more fine-tune adjustments here. So let's maybe make it like so. And here note that there's a minimum altitude and then there's a maximum altitude for the vertical scan tool. There's actually, I recently also spoke to one customer who's using this to scan some buildings in Florida. And it seems actually that there's quite an interesting industry for this specifically. Also because a lot of guys there still seem to be doing these vertical scans manually. And while manual scans, they might be a better option when you're flying near to the ground. But if you need to inspect some taller buildings, then I think vertical scans in an automated way, like you can do here with the UgCS, is just a must. Otherwise, it might be a real pain to fly all of them manually. So in this case, now, once we have these initial points laid out, if we'll need to make some more adjustments, we'll do them. But for now, you can see, so we basically have turn type is set to stop and turn. That's the one I would probably recommend with the vertical scans. And so then also we have the minimum and the maximum height. In this case, I'll just lower down the minimum height, maybe something like 5 meters. And then the maximum height, this one we can also, I think also I'll just lower this down a bit. And so, yeah, we have this camera selected. And then one of the main parameters here is actually the distance to the facade. So in this case, the distance is set as 10 meters, and we can actually measure this in UgCS. So let's just zoom out a bit. So here we have distance measurement tool. So we can then select it, and then we can, for example, here you can see this is the edge of the building, and then we can measure the distance until here. So in this case, you can see that this distance is 3 meters. So this just means we might need to put this just a bit further. So maybe somehow like so, and then let's again do the distance measurement to make sure this is more or less how it's supposed to be, and we can probably move this even further. So this is basically just the tool that I like to use to make sure that the distance to the object is how it's supposed to be, because well, the more accurate this will be, then the better, the easier it will be when you'll be doing data processing, because also depending on the distance of the facade parameter that's here, this will also actually impact how close will the survey lines be and what will be the overlap between the images. So I'm just gonna kind of eyeball it for now. I think this should be more or less good. Again, it's interesting how we're imagining this farmhouse would be like some tall building, but you know, I'm just working with what we have right now. And yeah, so also one thing, I'll just remove the set camera by distance and add the set camera. Oh, just add it again. Let's add the set camera by time, just because, like I said, I just prefer it that way. I think it's a bit better. For the M300 in here, this is, to be honest, a bit of a bug. You need to remove these extra zeros and only leave this tilt 0. This allows the camera to basically move upwards and center in exactly on the building. And yeah, so here we also have the forward and side overlap values. So here they're set to 60 and 30. In this case, I think I'll set them to 80 and 80. And yeah, so this is kind of how it looks like. There's two different patterns that you can use. So here currently you can see the vertical pattern, and alternatively you can also use the horizontal pattern to do the building inspection. So this is something you can start with. Also here you can see the vertical and the horizontal speeds that you can adjust, as well as the AGL tolerance value. So I think this is maybe at least a bit of a, we're kind of running low on time a bit, but at least this is a bit of an intro that you can use for doing flight planning on scanning vertical buildings. So I hope I also answered that. And let's see what else we have. So I'm just reading this question. Camera looks to a certain side when the drone turns at the end of the line, camera also rotates. Yeah, if I pronounce Dimitrios, yeah, right? That's her name. So this is what I was talking about when I was showing you the photogrammetry tool. So let's just quickly go back here. At least I think I understood, like answered your question. Just correct me if I'm wrong here. I think let's use this one. So what I was kind of trying to explain is that here you can see we have this change yaw action. If the change yaw is set with respect to next waypoint, I'll just maybe also just draw here on the route itself to maybe a bit better illustrate my point. So here you can see this is where the route actually starts. So it basically starts from this survey line here. Oops, sorry. So it starts from here. And in this case, you can see we have the change yaw set to 90 degrees. So let's then go here to annotation, and I hope, I'm fingers crossed this this should work. Right, it's a bit tricky actually because of the setup that I have with the screens. I think I'll manage. Okay, so basically if we have this set to 90 degrees, what does this mean? This means that as the drone will be flying like so this is the direction of the flight, then the heading of the drone, I'll just mark this in yellow, will be like this. And so of course, then, yeah, when the drone turns, then the heading here will be like that. And then when the drone will be flying back, then the heading, will be towards this direction, right? So this is if we have the change yaw set 90 degrees with respect to next waypoint. However, if you want the heading of the drone to, for example, constantly be, let's say, towards this side, right? Then what you would have is you would simply have to set this with respect to north. So you just need to figure out what's this angle with respect to north, and then you can set it like so. And then the drone will keep a constant, one thing I showed incorrectly is if the arrow was like this is not 90, this is 270 degrees. So this is a bit of my mistake. So yeah, it normally rotates like that. So this will be 90 degrees, and yeah, it's just on the opposite direction. And so here as well, this will be the opposite. So I apologize for the confusion if I caused any. So I'll now clear all the drawings. And so, yeah, then basically if you're using the yaw with respect to north, then this means that, yeah, it basically takes this angle to the north and then adjusts 90 degrees with respect to that. Easiest way how you can do that is you have this direction angle. And so you know the direction angle of these survey lines. And then to this, you can simply add 90 degrees. So for example, if the direction angle is like so, and then let's say you want the drone to be looking kind of like that, you just add 90 degrees to that. So in this case, this would be 197 degrees with respect to north, and then the drone will be looking towards this direction. Actually, we can probably test out my my theory. So let's do this. You can then select relative to north and then select 197 degrees. So again, it's 107 plus 90. And then let's just disarm the emulator drone real quick. Just a note, don't ever disarm a real drone when it's in the air. I'm just like doing it on the emulator drone to quickly move it around because it has to be in disarm state. So I'm just, I know you guys are smart enough, but I'm just like, just a side note. So now let's upload. I'm going to upload the second time as well. And yeah, now this should be okay. Let's do ARM. The battery emulator, oh no, it actually reset. So that should be fine. Now let's do auto mode, and if my calculations are correct now, the drone should be looking towards this direction. And by the way, on DJI drones, you also have the ability to turn on the simulator on the mobile app. So you can just turn on the simulator mode, and then every route, if you're maybe unsure how the drone will actually fly it, you can fly it from your office or from your home without the need to go in the field yet. If you just want to practice and make sure that everything will work and that the route will upload to the drone and that there's no issues there. I'll just wait for the drone to reach the altitude. I think it's almost there. And I think once it does that, then fingers crossed, it should look towards this side. And yeah, so you can now see the drone is basically 90 degrees with respect to at least this point here. As the drone will reach this corner, the heading will not change. And so it will keep the same heading all through the mission. And I hope that this was the question that I was trying to answer and that I managed. Oh yeah, I see that you wrote that. Yes, Suzette. So yeah, thank you. I see another question from James. So yeah, is upward tilt possible during a facade scan mission? I know we had this question previously in support. It might depend on what drone you're using. Because DJI, we're using their MSDK to basically control all the drones, and it can sometimes work differently on different drones. I remember we tested this on, I believe it was Inspire 2 drone, and even though manually you can like move the camera higher than 90 degrees, their mobile SDK simply doesn't really support that. So the way it worked was that, let's say if you enter in here 90 degree, well, let's say if you enter 10 degrees, it moves 10 degrees downwards. If you enter minus 10 degrees, it also moves like 10 degrees downwards. So it's just how the DJI mobile SDK interprets these messages. And yeah, in that case, at least it wasn't possible for us to move the camera upwards automatically. If you need to do that, maybe it makes sense to try to move the camera manually as the drone is flying. By the way, just a side note, one other quick and I think quite useful thing is that when you have your drone flying an automated mission, a DJI drone specifically, I didn't know this for a really long time, but actually it turns out you can use the pitch stick on the controller to make the drone fly faster or to make the drone fly slower. So if you want the drone to slow down during certain segments of an automated flight, you can simply, push down on the pitch stick and then the drone will slow down. Similarly, also, of course, you can control the yaw of the drone and yeah, do things like that. You can't control the height, unfortunately. We have had this question before, so you can't control the height in those cases. But well, okay, I think we are almost out of time, and this gives me a perfect opportunity to do a very shameless product plug in here. So I know a lot of you are still here currently on the UgCS trial. So I hope that testing the trial goes well for you. If you have any more questions, you can just send them to us at support@ugcs.com. And then over here, of course, you can see we have our perpetual licenses, so Pro, Expert, and Enterprise. So these do include the support for the first year as well as updates. But since they're perpetual, it also means you will own the license forever, basically, once you buy it. Even if you choose to not get any additional support or updates, you'll still be able to use this. So this might be something to look into for you. Or alternatively, we also have the subscription options in here for Expert and for Enterprise. Yep, and also similarly, if you want to try out UgCS Mapper, you can go again here to our site, so shop.ugcs.com. And then you can go here to UgCS Mapper and maybe try it out, because I think especially if you need to do some image processing, map creation in locations that are quite remote, this might be quite a good tool for you, I think. But yeah, so I'm very happy that you guys came to the training. I hope it was interesting for you and that you learned something that could help you in your flight planning. And yeah, we'll be doing trainings like this probably in the future as well. So if you want to attend some other ones, keep an eye out on our website. And plus, please do join our Facebook user group. It's already at 2.3 thousand members there. So yeah, we're also looking forward to seeing you there. So yeah, thank you everybody for joining and have a great day.